In these next few slides, I just want to relate some of these concepts of energy to some more biochemistry. So on this slide here, I'm showing a bunch of processes. We are starting off with carbon dioxide and water, and then this first arrow shows us turning it into glucose. This is the process of photosynthesis. This arrow here is photosynthesis, building glucose, which is this one right here, from CO2 and H2O. And then taking the glucose and building it into a chain. So this is our glycogen. So this is what you do in your liver and muscles when you take the sugar that you've eaten in your diet and build it into a long chain to store it for up to 12 hours. Right? So this is, the plant can do the first arrow, and then you eat the plant and do the next arrow to turn the sugar into glycogen that you store in your liver. And then in your body, you take the glycogen out of your liver and muscles bit by bit and break it back down into glucose as you need it throughout the day. And then you take the glucose and break it all the way down to CO2 and H2O, and that is cellular respiration, and that's what you breathe out. So there's a bunch of stuff going on this diagram, most of which is happening it's all happening in your body except for the only one part of this that isn't happening inside of you is this. We rely on plants for that first part, but all the rest of it is stuff that you can do. But the overall idea here is to show that as you move from the bottom left to the top right, you're gradually building bigger and more complicated molecules with more bonds. And you can see that quite clearly. Like down here, these are very small, simple molecules. This one's a bit more bigger and complicated, and this one's really big and complicated with lots of bonds. So as we go up this way, we're adding more bonds. So we're getting more and more energy stored. So this molecule has got a lot more E chemical than these molecules have. All right. It's also a lot more complicated. This molecule is a lot more complicated. It's bigger, more complicated, more structured, more organized. There's more of a pattern. There's more bonds. It's got more energy in it. But because of that, we also say that it becomes less stable. The more big and complicated something is, the more chances are that it's going to fall apart and collapse or something's going to go wrong. All right. As we go back down the other way, breaking down the glycogen into the glucose and the glucose into the CO2 and H2O, you are decreasing the complexity. It's getting less complicated, less big, less bonds, less organization, less pattern. It's becoming less energy. These molecules have less energy than these molecules, and the energy comes out as you break it down, but they are more stable. So I'm going to jump to this slide right here. And these terms are all kind of related. Something that is, starting with the left side here, something that is more organized, more order, more complex, has higher energy. This is the big complicated glycogen. It's overall less stable. And on the right side, we have things that have less order, less complexity, less organization. They have lower energy. This is the CO2 and H2O. They're all just little molecules bopping around. They are more stable. There's less for them to collapse from, kind of thing. All right. So you have to think about how these terms are related to each other. More order, more complexity, more organization means something that's less stable. Something that is less ordered, less complicated, less organized is a lower energy, but it's also more stable. And what is interesting overall is that the universe in general, wants to be more stable. This is what the universe is tending towards. And this is known as the second law of thermodynamics. So the second law, very, very simply stated, and there's different ways to say it, but the universe is tending towards, it wants to be more stable. And really what that means is it wants things to be not very complicated. It wants things to kind of fall apart, things to be not organized. You can experience this every day in your house, in your bedroom, in your kitchen. If you want to put all your laundry folded away and hang everything up and tidy up your bedroom, it takes a lot of organization. It takes a lot of time. You've got to put energy and effort into putting all that order and organization and complexity into your bedroom. It took a lot of energy. It took a lot of effort to clean everything up. But once it's all cleaned up, it's less stable, because what does it want to do? It just wants to all be messed up again. And you don't seem to have to do anything for it all to be on the floor and all messed up again, right? So it doesn't seem to take any effort for it to fall apart, but to put it back together and organize it all again takes effort. So, cleaning your house, cleaning up your bedroom, cleaning your kitchen, you're just going against the law of the universe. You may as well just give up, because you're never going to win that fight. It's always going to be tending towards disorder, which is something to think about. So what's interesting with all this, though, is that in a universe that wants this, or doesn't want this, but tends towards this, how can we possibly have life, like a human body? Because even something simple as a bacteria, not even something complicated like a human, but anything living is this. Like, our bodies are incredibly organized, incredibly complex. There's lots of organization. All the molecules have to be in the right place at the right time. All this kind of stuff. But that makes our body somewhat unstable. And our body wants to, the universe kind of wants to take our body apart, right? And eventually the universe will win. Eventually your body will collapse. There's one thing that will happen to everybody who's watching this video right now. There's only one thing that I can say that without a doubt will happen to all of us, because we're all going to have different lives, but there's one thing that's going to happen to everybody, and that is that the second law of thermodynamics will ultimately win, and your body will become eventually less ordered, less complex, less organized, and more stable. When you die, it will become disorganized, right? Now, you can go against the law of the universe for 50 years, 60 years, 70 years, 100 years, but eventually the second law is going to win out, all right? So then we have so the next question is, well, how do we manage to create order and complexity when it seems to go against the second law of thermodynamics in life? Well, that's going to be the topic of the next presentation.